Hello, my name is Yusuf Onur Mısırlıoğlu. I'm in Industrial Engineering Department, and in this semester I am taking Physics 101. And in this experiment I will evaluate the factors affecting the period of a pendulum. These factors will be length of the pendulum string and the angle between the string and the vertical cross section. By varying these factors, I will measure the period, which is defined as the time required for pendulum to complete one full oscillations.
Aim of the experiment. The objective of this experiment is to investigate how the length of a pendulum string and the angle of displacement from the vertical axis affect the period of the pendulum's oscillation.
Experiment summary. The variables that primarily affect the period of a pendulum are its angle with the vertical plane, gravity, and the length of a pendulum. However, according to many studies, small angles like less than 15 degrees have negligible effect on the pendulum's period. So after some equations, finally, the last equation that appears is t, which is period, is equal to 2p square root of L over g. In the first experiment, I will try to prove the linear relation between square root of L and the period. For larger angles, this approximate equation loses its validity entirely, and the equation becomes dependent on the angle. The period increases slightly with the larger angles, and the more accurate equation must be used in such cases. Basically, with the second experiment, I will prove this point.
Therefore, for these experiments, there are some required equipments: meter ruler, electronic stopwatch, protractor, 20-gram metal weights, inflexible ropes, and a metal structure. I started with setting up 3 ropes on the top of metal structure, then I hung 20-gram metal weights at the end of each rope. Then I measured the length of each rope. Measurements can be seen in the table. Starting with shortest rope, release each pendulum at an angle of 10 degrees. The time takes for each pendulum to complete 5 full oscillations using electronic stopwatch. Then using the pendulum period formula, I calculated the theoretical period for each length and determined the percentage error which is occurred owing to friction, air and sound, human reaction delay. Then I draw a parallel plot which is square root of length versus period. As a result from the graphics, it's seen that there is a linear relation between them. Second experiment, a 20-gram weight is hung from 38.5 cm rope. The pendulum is released from angles 10, 30 and 60 respectively. For each angle, I measured the time it takes for the pendulum to complete 5 oscillations and recorded data in a table. As a result, when the angle increases in the period as the angle increases. As a result, it can be seen in the plot, which is period versus angle, that when angle rises, period increases as well.